This is a demonstration of a chi-square analysis. We're interested in whether there is an impact of confidence building on females' exam results in terms of pass or fail, and to see whether they're significantly more likely to pass if they've done confidence building than if men have done confidence building courses. So because chi-square uses nominal level data and we're interested in the impact of confidence building training for men and women's pass or failure rates, we need to convert our exam data here into nominal level data. So click on Transform Recode into different variables, and we'll take the exam as the input variable and the output variable we'll call pass fail. Click on Change and it will appear here. Old and new values, well, let's go for the range of 0 to 60 being a fail, and we'll code a fail a 2 for now, and a range of 60 to 100 will be a pass, which we'll code as a 1 for now. Make sure that you have completed these two boxes here and clicked on Change, otherwise the OK button won't be visible. Now we've got our new variable here, pass fail. You'll notice that it has 2 decimal points. So if you click on Variable View down here, we'll just adjust that so that this has no decimal points, so it looks a bit neater. And we'll also just insert the values. So a value of 1 was a pass, add that, and a value of 2 was a fail, add that. Return to the data, and because we're going to be looking at confidence building and math skills building groups separately, we're going to split the file again as we did previously. We're going to compare these two groups. To conduct a chi-square analysis, go to Analyze, Descriptive Statistics and Crosstabs. Because we're interested in whether females' exam results will be pass or fail and more likely to be passing those than males who have done confidence building training, we put in the male and females in the row and the pass or fail in the column. Go to Statistics, make sure that chi-square is ticked, and we'll go for the observed and the expected frequencies and click on OK. So we've got the cross tabulation here. You've got the group of math skills and the group of confidence building, and then you've got them divided down by male, female and pass and fail. This is the observed count and this is the expected count. So 6 men passed the course who were doing the math skills, 2 of them failed it. But according to the statistics, fewer should have passed it and fewer should have failed it. And in this case, females on the math skills course had an observed count. There were 4 females who passed the course on the math skills training, and there were 3 who failed it. On confidence building then, we noticed that the males who passed, there were only 2, whereas we would expect there to be nearly 5 passing, and there were more failures than one would have expected. With females, there were more passing than would have been expected, and fewer fails than would have been expected. The next box tells us whether these results are significant or not, and in fact there is no difference, there's no relationship rather, between men and women and them passing or failing if they've done math skills, because the P result is greater than 0.05. Confidence building though, there does appear to be a significant difference. Here we can see that the p-value is 0.007, which is less than 0.01. And when we look back up here, we can see that females are more likely to pass than expected if they've done confidence building and less likely to fail, whereas males are less likely to pass and more likely to fail with confidence building. So confidence building has a much greater benefit for women in terms of passing or failing than it does for men, and in fact the results may be detrimental for men. One thing we must notice though with the chi-square analysis is that the expected count here, 4.7, 2.3, 5.3, 2.7, must always be greater than 5. So our sample isn't really big enough for us to be able to say with any certainty that confidence building has had an impact on women. So what we would want to do is to collect a bit more data and then rerun this analysis. Assuming then that we did have the right number of students, we'd report a Pearson chi-square value of 8.6, degrees of freedom of 1, and a p-value of less than 0.01. Okay, over to you then. I think it's a really good exercise to learn to transform your data into different types of data, from interval to nominal, for example. And I'd like you to make up your own hypothesis about the data. Transform any data that's necessary to make it nominal, but you don't have to do this. And let me know what your hypothesis is, what the chi-square analysis is that you run, and how you interpret your findings. Thank you.